What's going on, guys? Welcome to LetThereBeMath, and in today's video we're going to be looking at the integral of sec squared ax. Now you might recall from differential calculus that when you're differentiating the function tan of ax, you get a times sec squared ax. Okay? Now to make sure that this is in fact true, the way that we differentiate the tangent function is by first writing it down in terms of sine and cosine. And what we're going to do is we have two alternatives. We can apply the quotient rule, or we can apply the product rule by bringing this up as a factor to the power of -1. So I'm going to apply the product rule, and that's going to be sine of ax times cosine ax to the power of -1. And now we're going to carry out the product rule, so that means we're going to differentiate the first function first. That's going to be a cosine of ax times the other function, which is cosine of ax to the power of -1. And then we're going to add the derivative of this one times that one, so that's going to be sine of ax. Now the derivative of this function is going to require us to use the chain rule. So the first thing is we're going to bring that power -1 down times cosine of ax. Okay, so let's have that -1 over here. And then this whole function is going to become cosine of ax to the power of -2. And the final thing we need to do to this is we're going to differentiate the function inside. So that's going to be minus sine. So minus a times sine ax. Okay, so now that we have that, the next step is going to be to simplify this expression. So first, we notice the first term should cancel out on both, so that's going to give us a. Then for this term, we notice we have a minus sign that repeats itself, so that's going to become a positive quantity. And the sine of ax is going to be squared. So we have sine of ax squared. And now we have cosine of ax to the power of -2. So we're going to bring that down as cosine squared ax. Now at this point we can carry out that sum. So if we add up the two expressions, we get a cosine squared ax. And let's not forget that constant a that we had to begin with, so that's going to go in here. And then we're going to add a sine squared ax divided by cosine squared ax. Now since a is a common factor here, let's use the fact that cosine squared plus sine squared is going to be 1. So this means this is going to become a divided by cosine squared of ax. And if we recall from the properties of trigonometric functions, this is the same as a of sec squared ax. And that's essentially how we derive that result. So now what we're going to do is we're going to take this and we're going to say, okay, we already know how to differentiate the tangent function. So if we were to integrate this, we're going to get back to tangent. Okay, so let's write it down as a general formula. So if we make some room over here, let's just get rid of all of this. We know that we're going to end up with sec squared of ax dx is going to be equal to tan ax. But remember that we had an a at the front, so that means since we're integrating, we should have a 1 over a at the front, and that will complete our integral. And that's going to be plus c. So now let's apply it to a simple example. Let's say we wanted to integrate the function sec squared of 3x. Then all we would need to do is follow this general formula, and we're going to have 1 over 3 tan 3x plus the constant c. And that's our final answer. So in the next video, we're going to continue with some more integration techniques. And if you guys would like to see more videos from LetThereBeMath, make sure you hit the subscribe button, and I will see you guys in the next video.